Good day, everyone. Welcome to today's webinar. We'll be starting in a bit. Let's allow a few more attendees to join us today. Okay, we can start while the attendees are joining. Good morning, good afternoon, everyone. My name is Natasha Heyman. I'm part of the Cohesive Marketing team. I will be assisting the webinar today as moderator. A few administrative and housekeeping tips for today. Please take note that the webinar will be recorded and will be made available to every person that has registered to post this live session. All attendees are set to listen only mode, but you can post any questions or comments in either the question tab or the chat box beneath. We will address these at the end of the session. Should you have any technical questions or queries, please log it with the GoToWebinar technical team, and which is the help section, and they will reach out to you. Should you have any other audio issues, please remember that we will be sending you the recording. Now over to you, Murali.
Thank you, Natasha. And good afternoon to everyone. Thank you for joining this webinar today, taking your time. Welcome to the webinar series from Cohesive. So today what we will do is we will share some of what the insights and strategies in the next generation utility asset management, leveraging technology for efficiency and reliability. So today's webinar is brought to you from Cohesive. So Cohesive, we are a global full asset lifecycle engineering system and digital integrator. So we help clients harness the power of information and data within their business, both the physical and the digital environments, to design, construct, and operate their assets, right? So we assist in achieving transformational outcomes for our clients, both the environmental, social, financial, and other aspects and other goals. Yep. So this is the Cohesive global footprint. So we are present in 5 continents, and our presence in the Asia Pacific is very big. We have 3 offices in Australia, 1 in New Zealand, and more than 12 offices in Southeast Asia. Our industry sectors where we focus upon is manufacturing materials, manufacturing minerals, energy and utility, natural environmental, transportation, and building, right? So energy and utility is one of our key focus areas, and some of the blue chip clients are there on the list there, right? Of course, we are a platinum business partner of IBM. So some of the recent achievements to convey is we are the industry leaders in asset management technology and implementation services. So we are on the leader quadrant as per the Verdantix survey for 2024. And the other one from IBM, what we have done is we have been awarded as the Partner Plus for providing sustainability software for one of the blue chip utility companies in the US, right? So you're on the safe hands on the asset management side of services and on the digital integration side. And so today's webinar, we would have 2 distinct streams. So first we would start with understanding the utility landscape, and through that what we would discuss is about the challenges what utility industry faces and the opportunities what we have, which will lead towards discussion and suggestion and recommendation of solutions and strategies to alleviate those challenges. And the second stream would be focusing upon exploring how IBM Maximo application suite can bring the best for the utility industries, right? Following that, we will have a short Q&A. So I'm Murali Krishnan. I'm your webinar host today. I'm a business development manager based in Cohesive, Australia. So let me introduce our eminent speakers for the webinar today. So we have Tony Turner, who is our pre-sales and innovation director from EMEA. So Tony, based in the UK, has got more than 30 years of experience in asset management, specifically in the industries of utility, oil and gas, defense and rail. So he has sold many Maximo and enterprise solutions, asset management solutions to clients, including ADNOC Group, KOC, KNPC, ADWEA, SSE Networks, NIE Networks, Land Forces UAE, National Guard Kuwait, and many more. So Tony has led many of our enterprise programs around the world for numerous clients for Maximo implementation. Our second speaker, Damien Degovia, he's our APM lead consultant from South Africa. And Damien is an industrial and a systems engineer. So he has got a vast areas of interest, but his true area of expertise is in the IoT monitoring and predictive maintenance. So he is leading various research programs within Cohesive, focusing on the APM side, and he's our leader for the IoT and AI community within Cohesive. So with that, what we would do is I would invite Tony in order to discuss the challenges and opportunities which we have within the utility industry and start the webinar. So Tony, I would like you to, thank you.
So Tony,
Sorry.
you can just share, go into presentation mode, then you're all set.
Can you see this?
We can see it perfectly. So just go into presentation mode.
The trouble is, every time I do that, sorry. How's that? We got it?
Not yet. No, not yet.
Oh, wait.
There we go. Perfect.
Yeah, can you see the PowerPoint? Because I can't.
Perfectly. Perfect.
Still?
Yes, Tony.
Yep, perfect.
All right. Sorry about that. Okay, sorry about the technical issues. Okay, so challenges and opportunities. Murali, I think we're in the UK probably having very similar to you. These are some of the problems that people find. Aging infrastructure. In the UK, some of our utility assets are over 200 years old. They're not designed to last that long, so lots of failures in terms of underground pipes, in terms of cables, generation, water treatment plants. Another one is spatially dispersed assets. So the assets are all over the country. They're not in a single location, like in a power plant. Regulations and safety. So because it's a regulated industry, lots of regulations. I think the regulations vary country to country, but they're still underlying the same concepts, that it's a service that is required, it's critical national infrastructure. Obviously, asset performance and reliability is a big issue, as well as capex spend. One of the big ones, though, we found in the UK, and I think it's worldwide, is the change towards the renewables. In the original setting up of the national grid, all of the heavy-duty coal-fired power stations were in the centre of the country, and then Spurs came out, reducing the voltage, reducing the current, until you got to the coast. So consumers were picking up their electricity from the grid, and it was radiating out from the centre. With renewables, we've now got lots of wind farms. Wind farms tend to be on the coast or offshore, as well as solar. And in the UK, solar is in the south of the country. Also, what's happening is the generation is now happening at the peripheral and going inwards, rather than being generated internally in the middle and going outwards. And that is having to make massive investments in changing the way the grid handles the high voltage and the high currents coming from the coast. So those are the challenges we're facing. How about you, Murali? Similar in your region?
So in ANZ specifically, what we have is we have a lot of emphasis for regulations and safety. So this is regarding the bushfires and the other areas. And we also have a lot of penalties over to the operators for asset performance and reliability. So this is to ensure the network is always available. And also there is a little bit of an challenge in the capex spend what they can to build their infrastructure. So this has been regulated, and the operator has to go back to the government in order to give them the justification as why the capex is needed. Renewables is other area, as you say. Yes, there is a lot of similarities between UK and ANZ on the utility side. Yes, I agree, Tony.
Yeah, I mean, when I was working at Scottish and Southern Electricity, I was doing the implementation there. The lead engineer on the client side had come from Australia, and he was telling me the story that there was a bushfire where a lot of damage, people lost their lives, and basically the directors of the company were facing prison time because they said if the network had failed, if the pole had fallen over and caused the fire and it hadn't been maintained, they were liable. So it was literally, it is very serious. Okay,
yes.
So what we're going to be talking about now is basically some of the challenges. One is my particular bugbear is linear asset management, and I'll be talking about that, but also talking about risk management, regulatory requirements, and mobile. And then we'll move on to looking forward to asset performance management. So first is linear and the linear challenge. And the challenge here is traditionally in water, for example, you have a hierarchical approach. You've got a water treatment plant. It's broken up into various functions like raw water, filtration, clarification, treated water. And then within that, you've got assets like the sand filters, the clarifiers, the pump stations, the pump sets. Hierarchy approach works really well. But when we start talking about transmission and distribution operators, they want to see connectivity. The underground assets don't fit into a hierarchy. So sewer lines and water lines, they're not hierarchical, they're linear. So they have linear attributes, they're spatial because they're all over the country. And as you can see, the hierarchy approach fails. And the response that we've had from customers, people like Affinity Water, Southeast Water, South Stats Water, they're saying, okay, we let GIS own the underground assets because GIS can manage it. But if GIS is managing it, GIS is not a work management system, and it doesn't hold the asset history. So yes, you can use GIS and it works very successfully, but they're not gathering the history. So those are the problems we're seeing that they're facing. And when they're reporting to the regulators about how many kilometers of underground pipe are aging or corroding, they can't give the answers. We look at power, similar story. We've got power stations and we've got substations. And again, power stations, you've got the fuel, you've got the units. Within the units, you've got the boiler, you've got the generator, you've got the transformers. So the hierarchy approach, again, works well in those environments. But when we look at the grid, it doesn't work because we've got distributed, again, same challenge as water, distributed assets, changing voltages, millions and millions of records. As an example, SSE had 11 million records in their asset records in their database. Northern Electricity, we've got over 2 million so far and counting. And they need, again, these spatial references. But some of the assets in the substations and the power stations, yes, they're good assets to manage. But then you've got things like overhead lines and the poles, 1 million poles, wood poles. We need to cater for those. So the challenge, they've got many systems. Every time we go into utility, we see a plethora of systems. They may have a network control system. The network control system may not be complete. For example, some of the utilities I worked on, they don't have low voltage assets in. the network control system doesn't hold things like the buildings, the poles, and the towers, or the pump stations. The GIS system, GIS is very good. It's got all the spatial assets. It's got the overhead lines. It's got the underground cables. It's got the underground pipes, but it doesn't show the internals of the plant or the power station, substations. It may not show the connections at the houses, so it only stops before it gets to the consumer. Then they've got CRM systems, and the CRM system does have the consumer information. It knows about the meters, but it doesn't know how that meter gets its power. And then they have other asset decision support tools, such as CBRM or Copperleaf, which again, they don't cover all the asset types. They don't have spatial referencing. They don't model the connectivity, and they need more data than is available from a single source. And then you have the little side things like vegetation management. As Morales says, bushfires. Well, bushfires happen because people are not doing the tree cutting or cutting back the vegetation close to the lines, and you get shorts. And they rely on multiple spreadsheets. And again, a real life example, one utility I implemented, they said they had some spreadsheets. We started doing an investigation. We found 300 spreadsheets in use, tactical. And what happened is the user had said, I need this to do my business. He took a copy of the database from the GIS system or from the EAM system, and from then on worked on the spreadsheet. And what that meant is you had many versions of the truth. There was no single version of the truth. When that utility had to report to the regulator, there was a discrepancy of 300,000 wood poles. How many they said they had and how many they had in various different systems. They didn't know how many poles they had. So what's the solution? Use linear assets and combine it so you have a holistic asset model with the point assets, such as the transformers or the pumps, with the linear assets, such as the overhead lines and the underground pipes. For the underground pipes and for the spatial assets, we're using linear referencing. And for normal assets, we're using a typical hierarchy in a consolidated asset model. And also, we want linear work management. Again, when you're doing tree cutting, you're doing it on a linear basis. You're using linear referencing to say there's trees that need to be cut. They're actually 250 meters from this reference point, this substation on that circuit. So they're using linear reference to say where the work needs to be. Using dynamic job plans. So if you're doing vegetation clearance or if you're doing walk the line, the length of time it takes and the number of resources it takes are dependent on the length of the line or length of pipe that you're actually monitoring or walking. So how do we address this? We allow the users to identify certain assets as being linear. Within linear, they can be virtually segmented, so not physically segmented. So if that circuit is going through a rural area and then going into the city, there's a change of use. If the attributes change from the size of the cable, the size of the pipe, to the insulation, again, that changes over distance. If it crosses a road or a river, again, we've got a feature that we need to worry about and address separately. And when we're doing work, the work is linear. So supporting with linear work orders and using things like features, attributes, and also relationships. So the relationship of how does this pole, the pole carries the circuit at that particular point, or the spur intersects the circuit at that particular point. Some of the work use cases, damage to overhead lines. So the insulation could be damaged on circuit B35 at pole number 35121. Or they need to, and what they need to do is replace the insulation from 0 meters to 12 meters from pole 35121. A tree encroachment, so they can report a tree encroaching the circuit, is 35 meters from pole 356, and the tree is 2 meters north. So they know which tree they need to get to, how easily find it, and work on it. And they'll use GIS there to actually navigate them to the pole or to the tree. When they're doing line inspections, they create a linear work order. So they're working on circuit B35, they're starting at that chainage, finishing at that chainage, and they measure their daily progress. One of the challenges there is typically the engineers are being sent out with 200 or 300 work orders. These are 200 or 300 assets to be inspected on each day. They need to navigate there, need to know which asset they're monitoring and what data they're recording. So, do you use linear? Do you use GIS? Answer is both. GIS shows the linear assets in a spatial view. It helps you navigate. It helps you plan your work by saying, let's select all work in a certain within a certain polygon, or by distance from a location. Whereas linear holds the linear attributes, the asset attributes, the type of cable, or the type of pipe, and also what work history is against that asset. So I use both of those in combination. We believe that's the right solution. There's a typical view of at the bottom, the EAM system's view of the linear asset, and at the top, you've got the GIS view. Okay, so those are the feelings about that. Next section was risk management. And again, I'm quoting a live example here. In the UK, Ofgem is the regulator for electricity. There's a license condition. Basically, any operator doing transmission or distribution has got to have a risk management methodology, knowing the asset performance, the asset health, and the asset criticality to calculate the risk. So there's conditions in the regulator. If they don't report on this, they get penalized. If they don't report it frequently, they lose their license. And they set up for a number of different asset classes. Last time it was 23 different asset classes. They have to do this report on every single asset that they have. So it's, one solution is computer-based risk management, CBRM, from EA Technologies. Many customers are actually just using spreadsheets, but it's a massive challenge to keep those spreadsheets up to date and manage them. The way it works is getting asset information, asset management information coming out of the EAM system, in this case, Maximo. The system will calculate the health index of each asset. So it looks at the asset. The asset could be a wood pole. What's the expected life of the asset? It's 40 years. And it's 20 years old. So basically, it's halfway through its life. So before you've even started, it's 50% health index. But then we look at the condition. Obviously, we've been doing monitoring. Is it leaning? Are the stays damaged? And calculate the overall health score. Then, how probable, what's the likelihood of failure of that asset in the next 10 years? So we calculate the probability of failure. But that's just one aspect. We also look at the criticality of the asset. There's this wood pole in Newbury Town Centre. If that falls over, 10,000 customers lose electricity. And while we were actually having a workshop on this particular project, I got a phone call from my colleague saying, I'm in a farm, a pole's fallen down, can you ask them when they'll fix it? And the answer came back, how many customers is that pole supporting? It was one. And they said, don't wait, don't be in a hurry, it's going to take several days. If it was in the town centre, they'd be out there in like a flash because there's 10,000 people. So what is the criticality of the asset? We know the probability of failure. Put the two together, we calculate risk. And the risk score is actually calculated as a monetary value per asset. That is then rolled up to the total network, so they know the total risk value of the network that the operator is managing. So CBRM is being fed from Maximo. It's replaced 100 spreadsheets, and we're getting on each record, we can see what the health is, what the criticality is, and what the risk is. And this is basically just showing you on the left, the health index today. Most of the assets are in a very good state of health, and some of the older assets are deteriorating. But if they don't do an intervention in 10 years, you can see that the shift towards the assets which are now critical is massive. So this is how they manage their investment. They're looking at this model every year to say, this is our plan for next year. We're going to address those older assets or the low health, the high risk assets first, and that's how we allocate our budgets. So risk management tool, CBRM, managing 23 classes, and they're producing Ofgem standard reports. Talking about Ofgem, I apologize, I'm from the UK. We have our own regulators. We've got Ofgem for electricity, we've got Ofwat for water. We're also dealing with URNI for Ireland. But there are regulators all over the world. What Ofgem have been doing, and I think this is probably similar, is they're doing something called rigs reporting because they've got 12 distribution operators, 3 transmission operators. They need to make sure that everybody's reporting the same things the same way. So they've created this spreadsheet, which needs to be populated every year. It's what I call the mother of all spreadsheets. It's got 132 tabs. Each tab has 110 asset classes and about 100 columns. It is massive. And they've been, in the past, they used to have 5 or 6 engineers working for 6 months just to populate this to produce their annual report. They're now getting most of that data directly out of the Maximo solution. But it's feeding that spreadsheet so that when we're doing work, we know what is the work driver. Is it because of flood risk? Is it because of aging assets? Is it asset replacement or network reinforcement? So they know the reason they're doing the work. They know the asset they're working on. It's a 32 kV transformer. So they know the reason, the type of asset, and how many they're doing and how much they're spending. And so they're all reporting in the same language. The operators are paid by revenue, obviously, and the revenue consists of a number of things. Outputs, that's how much electricity they're delivering, but also what innovation, what are they doing to enhance the network? And they're getting incentives. And we say incentives, and people think, okay, this particular utility, their annual incentive budget was £100 million. It's $150 million. So it's big money at risk here. If they comply, they get the bonuses. If they don't comply, they get the penalties. Another requirement is CBRM, price controls. For water, similar sort of incentives. This time is customer service and also service to the operator. Again, in Europe, we found that they're separating wholesale and retail, which is a bit weird. So a water company typically supplies all the customers within the region, so they're the wholesaler. The retailer is the person who installs the meter and charges you for it. So you get the bizarre situation that I get my water, it's supplied by Bristol Water, but I'm paying British Gas for my water because they're separating the businesses, yet the two have got to have Chinese walls, so the wholesaler doesn't know how much the customer's paying or who the customers are, but the retailer doesn't know how much it's costing to deliver the water. So there's a whole, talking the same assets, but we've got different views on the same assets. And then there's allowing, they have these asset management periods, 5-year periods where they're price controls. So the government or the regulator is telling the operators, this is how much you can charge for your water. So their price controls is central. And we're finding, we believe you've got similar challenges in APAC. Mobile. Okay. First thing, T&D companies, they're geographically distributed. I don't need to tell you that, you know it. The majority of your workforce is probably mobile. So there can be thousands of mobile users. Therefore, they can't work on paper. They need mobile tools for doing work management, for doing inspections. And the largest enterprise asset mobile use cases are typically T&D utilities, and the other one is facility management. And Maximo and SAP are the predominant systems in that space. So when I'm talking about mobile, I apologize, I'm going to be talking mainly Maximo, because Maximo is an open system, and there's about 20 different mobile solutions available from different vendors. SAP, not so many, and the other EAM systems tend to be fairly limited in the mobile solutions. That people either use the vendor's mobile solution or they use a custom bespoke development. Some examples of mobile use cases for electrical distribution, doing overhead lines inspections. Sounds simple. Everybody I keep talking wood poles, and people call me Mr. Wood Pole, but there's 1 million wood poles in a utility. Eskom's got 7 million wood poles in South Africa. And for each pole, they've got to inspect it every 4 years. Each inspection, they're capturing 60 to 80 different readings or measurements. What's the angle of lean? What's the degree of decay? What is the mold damage? What is the bird damage? Has somebody been shooting out the insulators with their doing rifle practice? Whatever. They're taking 68 readings. It needs to be done offline, and it could be done in adverse weather conditions. They could be in the middle of the bush. They could be up a mountain. or they could even be underground. But basically, they're not going to have connectivity to the internet. So they need a mobile solution which works offline. In the water industry, not so much inspections. It's difficult to inspect underground pipes, but they know when it's a problem because they see a leak. So the leak fixing, when there is a leak in the road, typically there's multiple visits. Somebody goes there to inspect the problem. Then we'll get a crew in. We'll actually put a street works up and do traffic control, excavate, replace the pipe, and then reinstate. Reinstatement is one of the big arguments because they always say, oh, but the road was bad before. No, it's, and the local authority says, no, the road was perfect. So they have a photographic record before they did the job, during the job, and after the job, so they can prove that they restored the pavement. And you've got other complications like street works and permits to work. So this is just a short list of some of the Maximo mobile options we've worked with. There's another 10 or so. I know over 20 mobile solutions for Maximo. And the last one at the list there is custom development. Now, each one's got different technology. Any utility will need disconnected mode. You need to be able to work disconnected and then synchronize the data when you get back into contact. Some of the criteria, we need to be able to do maintenance work orders. We need to be able to do inspections. We want to capture details of assets. One of the challenges, again, mainly electric utilities, the inspectors go out and walk the circuit. They discover 3 poles that weren't on the system. So they actually have to capture details of new assets. There's a transformer on that pole which they didn't know about. They need to capture the details of the transformer. So need to have that information. They need mapping functionality. They're walking along across fields. They don't know where they are. So they need a map on the device to say, this is where I am, and there's the asset, and I'm looking at that asset, so they know which asset they're working on. It's got to have a decent user interface, so that if you're in a blizzard or in a snowstorm or it's raining and you're wearing gloves, you can actually still use the thing. Risk assessments. You're going to a substation or a remote pump station, you need to do a risk assessment before you go on site and pass that risk assessment. Otherwise, the mobile will not allow you to proceed. And other things like managing of van stock. So very often the inspectors or the workers have stock within the vans, gaskets or spares, so that when they go to a location, they're carrying spare parts. Okay, so mobile, lots of options, lots of considerations. It's not necessarily one solution that fits all. Find the right solution for you. So with that, if there are no questions, I'm going to pass over to Damien.
Perfect. Thank you very much, Tony. So I'm just taking my screen. All right. Okay, perfect. So thank you very much, everyone. All right, so maybe just to begin as a precursor to this, we'd first like to go through just asset performance management, and then leading into that, some ways of implementing that, and then concluding with some other specific details around systems. So when we're talking about asset performance management, what we're really talking about is this natural extension from an enterprise asset management system, with the intent at least to try and shift the prioritization that we can make during our maintenance decisions. So for those of you who may know Reliability Web, Terence O'Hanlon, him and Mary Bunzel from IBM did some research in terms of what mature organizations versus slightly less mature organizations try to do, or what their priorities are. And effectively, the goal at least is that mature organizations tend to spend more time planning than they do actually touching the asset and solving problems directly on the asset itself. And so this sort of enhances or reinforces the desire to be a lot more proactive in terms of our general maintenance approaches. And so how exactly do we do that? Well, we know the various different regimes of maintenance. And this is research done in the US by the Electrical Power Research Institute, EPRI. And effectively what they looked at doing was, you can arbitrarily think about this as for a particular asset class. If you were to go from purely just rental failure as opposed to planned, as opposed to predictive, as opposed to proactive, each subsequent step has a reduction of total life cycle cost against that particular asset. And we know this intuitively, but at least from EPRI, they've actually put some numbers down to that. So an expectation moving from a $50 arbitrarily spent 1.6 times less to planned, and 3 times less from planned to predictive, and then from predictive to proactive. Now, again, not every asset is required to have these specific maintenance regimes, and it is largely specific to some of the critical and more important assets and infrastructure. So the question at least is, we know this stuff, we understand this is some of the founding principles of reliability engineering, but what does this look like in a modern era? So traditionally, when we started to identify a lot of the condition-based maintenance, which forms part of this more proactive leading up to predictive maintenance, there would be a typical inspection that's done by an external device. So that's indicated in the first F1 bucket there. So effectively what happens is we go and we inspect an asset retrospectively. We look at it, we define some quantifiable measure to determine what its condition is. We walk away from that asset and we go to the next one. And on our mobile device, on our EAM system, on our piece of paper, on our job card, whatever it is that you have in front of you, you've noted that that asset is in a certain condition. We turn around, walk away, and it spontaneously combusts and disappears off the face of the earth. That asset's condition is no longer valid. And so by doing this relative condition, what we're effectively trying to do as an outcome is to use that information to prioritize some of our worst performers. So that is typically what most advanced customers, and similar to what Tony referred to in terms of the CBRM, the risk management on your condition assessments. That's typically what a lot of customers are doing. And for certain asset classes, it works perfectly well. However, if we start progressing and start incorporating some of the newer data sources that we can get our hands on, an assimilation between IoT and OT data, as well as some other unstructured information, such as operator insights. And now with the leverage of large language models, we can take arbitrary text, commentary, notes that have been made, dictations, and use that to try and quantify and better understand what the current condition of an asset is. So by doing this, we're effectively having a direct indication as to what that asset's health is by incorporating some live data. And this allows us to then prioritize inspection activities and be a lot more proactive in that approach. And again, in this instance, if the asset burns down, we can know exactly when, where, how. So we have a real-time understanding of what's going on in our assets or our portfolio. If we then move towards the third outcome here, which is that future condition. So how can we be more proactive in anticipating what the condition of an asset will be? This starts to better understand, both from a statistical perspective as well as from a first principles perspective, what are the fundamental things that constitute that particular asset's future condition. And so when we start going into the future and predictive maintenance, there are obviously further complexities introduced and further inaccuracies introduced. And so our planning needs to be reflective or indicative of that. So when we start to do that future condition, what we're really trying to do is try to prioritize some of the critical replacements and be a lot more proactive in our capital investment and capital planning strategy. So the overall objective of asset performance management is to try and create some automated, repeatable, reproducible, and most importantly, from a technology perspective, scalable method of being able to roll this out to the respective asset classes. Now, it's not just us that are saying this is cohesive. Here, for example, we have Gartner, who's another independent research institute, and they talk very similarly to these types of use cases, where we have our traditional EAM system, such as a SAP PM, a Maximo or Maximo application suite, Info EAM, the likes. These systems now need to start incorporating IoT and OT data. However, the fundamental design of these systems were not built to do so. And so what we see now is either OEMs in specific asset classes or specific equipment itself starting to develop vertically more IoT and analytics capability and capacity. Whereas what we also see, some of the EAM vendors are now going downwards, trying to reach the physical assets and touch them on the plant. And so there's this back and forth between who is going to reach that middle ground, or what is the best point of that. And the idea, at least again, is to take all this OT and IT data into our EAM softwares, and then to elevate that into an asset investment planning software, or capability rather, to be more prominent or more focused in terms of our asset investment. Now, just to hit the point home, Vedantics, a separate research institute, has concluded at a similar outcome, where the idea here is to be better at planning ahead of our long-term, or better to have long-term planning in terms of replacement and actually executing that down. So having a high-level strategic view from a long-term CapEx perspective, and then having the necessary tools and technologies to bring that down to a tactical and operational level. A key thing, and this now I'm starting to introduce more technology to this from the asset performance management front, that Vedantics covers that I don't think is explicitly detailed in the Gartner discussion, is that we do have a number of these APIs. And so essentially Vedantics' view is that some of these systems won't be aggregated into a single system itself, but rather systems need to have capabilities to interface and to talk to each other. And this is all the way down from a SCADA, PLCs, any of the actual OT data on the plant, to be able to be elevated either through aggregation of edge computing or have some kind of cloud enablement, which can then be processed either in the centralized system or through separate industrial analytics softwares, where we can do some of the predictive maintenance. So what we can sort of see moving towards at some point is each of your OEMs for specific equipment would potentially go and design a predictive maintenance software feature set, IoT, OT sort of synchronization tool that you could then plug into another sort of EAM system. And we could have predictions coming from the OEM and predictions coming from your own internal system, similar to how a vendor or an OEM might specify a certain planned maintenance frequency. You will also then go and create your own planned maintenance frequency and try find a middle ground between the two. This is what we start to see in terms of predictive analytics and predictive maintenance going forward, that we'll have multiple predictors indicating the same thing. And so how exactly do we do this? Now, again, there are other systems out there. We at Cohesive have access to multiple of them. However, we believe that IBM Maximo does encompass some of those particular elements that we've described earlier on. However, the fundamental principles that I'm going to outline here are still applicable to some of the other systems and can be used as an evaluation. So just as an overview as to what exactly IBM Maximo covers. So Maximo is part or a legacy solution that has been evolving and continues to evolve for the past 30 odd years. It's one of the largest in the industry, and it incorporates a plethora of functionality, from workflow automation to procurement to supply chain management, you name it. Incorporated into that, there are specific industry solutions. So Maximo has tailored some of its processes out of the box towards specific solutions, and these are quite in depth. Sitting on top of that, what the folks at IBM have done is they've started to expand Maximo into a variety of, into a suite rather. And so Maximo, which was previously, Manage, which is previously known as Maximo, has been effectively put into a suite with a number of other existing IBM products. Monitor, which effectively allows you to connect to real-time data and to process that in real time. Deploying anomaly detection algorithms and some of IBM's proprietary AI accessed inside of the solution. Health, similar to what Tony mentioned on the CBR, the condition-based risk management. In health, we can also have a 360 view of our assets, consolidating all that into very simple views that then allows you to trigger off work orders based off of the existing health of an asset. And that health can be informed both by the retrospective data that we can capture and store and manage, such as your condition assessments. It can also consist of live streaming data coming from those assets, either IoT that you explicitly define onto the actual piece of equipment, or from OT data streams that we can then pull from NoSciPi or any data historian that you may particularly have. Then also predictive maintenance, as we've described, is fundamental towards this shift, and health can also incorporate that. And by all of these functionalities being integrated together, we can have what IBM has defined as their version of asset performance management. In addition to that, there's another bunch of applications within the suite that we can touch on perhaps in a later stage. Another key thing, at least, is why the change. So like I mentioned before, there is a large shift towards the asset performance management. And so your EAM system needs to have these particular capabilities in place. A second one, at least, is because we're talking about IoT data and because we're talking about this industry 4.0, I was recently talking to a customer who has a specific asset that transmits 70,000 data points at a frequency of, some of the assets at 3, but the new assets they're getting in at 1 second, and they have multiple of these particular assets. So plugging that directly into a traditional system that's sort of just hosted on a virtualized environment just won't cope. So there is this real requirement for systems to be flexible and scalable from an actual usage perspective. So being able to handle either a very low frequency of data streaming into that 70,000 that I've mentioned earlier. And that's where IBM has also partnered, or actually procured and owns now, Red Hat OpenShift. So for those of you techies on the line, OpenShift effectively is a modernized tech platform that is sort of cloud native, which allows you to basically move from that hybrid cloud strategy that you may be wanting to pursue with your maintenance systems. So how exactly has this been implemented? Well, I've got a few very brief use cases that I'd like to cover. And just to be very and explicitly clear here, these are a combination of some of the asset performance management applications and Maximo. So these are IBM specific use cases as well. So in this particular one, we had a transmission system operator, ESLES, and effectively, as per usual, we wanted to reduce some of the costs incurred during maintenance. What we effectively were able to do is, by levering some of that anomaly detection, we could then have better understanding of what the true root cause is, weed out the false positives, and only focus on the true alerts that were coming through. And by doing that, we cleaned up what would be known as a false negative, which allowed us to have more accurate, proactive strategies in terms of rectifying and resolving this particular asset. We also have a regional water utility who, unfortunately, we can't specify the name in the US. And effectively, similar approach. What we tried to then do was leverage some of the smart data coming from the IoT and the sensors that they do have. Pumps are everywhere. Pumps can do a lot of things with vibration analysis. And if we try to consolidate those instead of having specific point solutions across different areas in the processing plant and aggregate those together, we can better understand the spatial temporal relationship between various assets, and so determine if there is a relationship between one asset failing and another asset failing. By doing that, we can actually improve the reliability and reduce that maintenance cost, of which we can go into these a little bit later. Now, the last point I want to address, it does say moving to Maximo application suite. We do have some Maximo customers on the call, but some of the fundamental principles here I still articulate are important. Most of the customers, I want to say all the customers that we are talking to nowadays, have at the back of their heads a hybrid cloud strategy or something along those lines that they need to move towards. And some of the fundamental principles over here are still applicable to being able to do that. Just as a note for some of the Maximo customers, so end of life is at 30th of September 2025. This is from Maximo 7.6, which means it will then move over to Maximo Application Suite at a later stage. All right, so in terms of moving to a hybrid cloud approach, and specifically moving from Maximo 7 to Maximo Application Suite, there are a few different things that need to be taken into consideration. So often when we're moving from different solutions or moving up to a more advanced version of a particular solution, there's some conversion and licenses. And so a license check is imperative to perform. We at Cohesive have predefined methods, sort of standard and repeatable ways of doing this, both for our own sake as well as the satisfaction of our customers. And then once we perform the license check and we understand the commercial change, we then perform a health check, which aims to understand if there's any customizations, what degree are those customizations affecting or could affect a potential upgrade. How is the customer currently using the system? What applications are being used? What applications are not? Kind of looking at stock take between the licenses you've had, the functionality you should be using, should not be using, have been using, want to use, and trying to consolidate that in a really good way. A log analysis, well, again, this is part of our predefined methodology where we've got effectively a very long-winded or a very well-trained log analysis tool that we've been populating and building for as long as we've been in business effectively, that tries to aim and identify specific errors within the actual deployment. That could either be something like a Java leak, it could be poorly written SQL that may have performance implications, dropped indexes, any sort of very deeply technical information that has been created through the actual use of the system. And lastly, a functional assessment. So this is more of a business advisory discussion where we go on site and we try to identify what the business need is and what the system capability is. And usually what happens is when a system is procured, that is tightly coupled. And as business progresses and systems progress or stagnate to some degree, depending obviously on the solution or the particular situation, there's a drift between the business requirements and the system capability. So the functional assessment is meant to firstly identify and quantify that difference, and to then prescribe methods of being able to consolidate that. So everything that we offer, from the license check, health check, the log analysis, and the functional assessment, all of those are predefined. They follow a set methodology, and it's based off of our learnings that we've had with multiple customers. Once we take all of that and we conducted all those separate exercises, we consolidate that into our advisory services. And so we have senior directors coming in, reviewing all the outputs of these, sitting with the customers and trying to best position how they should approach their hybrid cloud move or their shift. And so there's things along in terms of actual downtimes. Do we do a pure technical upgrade? Do we do a technical plus functional enhancement? And there's sort of reasons and justification for both. If there's a heavily customized system, how can we leverage some of the newer capability to remove those customizations and improve that moving forward? Then what we do is our advisory services consolidate the discussions we have with the customer along with all the information that we've previously gathered, and we put together what we think is the optimal upgrade methodology that is then presented to the customer, where they can then review, assess, understand, and within that there'll be things along the lines of tentative or high-level costing, high-level timelines, key milestones for them to better articulate what the budget will be, budgetary periods, how that affects it, and then also to identify what the functional enhancement roadmap might be. So again, to try consolidate that drift between the actual system usage and the business requirement in the most amicable fashion. So I think with that, that is all I have at the moment, and I think I'm going to move to the next slide. Natasha or Murali, do we want to start the Q&A?
Yeah, we can move over to the Q&A. Over to you, Murali.
Yeah, thank you, Natasha. Thank you, Damien. Thanks, Tony and Damien. It was a wonderful session, full of insights. And we have, I think, a few questions there. And I encourage the participants to type out some more questions if you have. So the first question is to you, Damien. So this is on the APM side of things. Do we have library of failure modes and strategies for utility industry asset classes in Maximo?
So there's 2 points that I want to add to that. The first is we as Cohesive, we do have a system of record to support that. But then you also have other vendor solutions that are supported. So I think, Murali, you can maybe talk about the AssetWise suite, but I'm going to quickly focus on one of the recently released versions of IBM. So IBM recently purchased another company, and they've created a product called AssetWise Reliability Strategies. Apologies, that's Murali's one he's going to talk about. Reliability Strategies is effectively what you've just described. It's a set of predefined failure modes that are prescriptive to, I think, Tony, correct me if I'm wrong, it's like 17 or 70,000 as well.
Okay, it's about 800 different analyses by asset class. So basically,
yes,
they're doing reliabilities. They've got identified the asset classes, and they've got the models to actually calculate the reliability strategy for each one.
Correct. And the whole point of this, I think, and this is maybe where the question's coming from, is that RCM, reliability-centered maintenance, is highly, highly, highly valued, but it is one of those things. I always describe it as if you get a dog one day, the puppy looks very cute, everyone's very keen to get it, but then you have to clean up after it, you have to feed it, you have to take it for a walk every day. It's a commitment that you have to make. And so when it comes to RCM, it is just that. And what a lot of the vendors are trying to do is trying to supplement that by being able to create or make the technology as easy to use and to support some of the main factors that cause users to not follow through on the RCM bit. But I think, Murali, maybe you can talk a bit more about AssetWise reliability, or I'm comfortable to take it if you'd prefer.
Yeah, so So we do have solutions supporting the reliability strategies for equipment, and we have an asset-wise APM solution to supplement providing some of those strategies. We can expand upon the failure mode effect analysis in order to develop the dominant sort of failure modes for assets, and then come with an appropriate strategies for that. So we do have options. Of course, Maximo has an inbuilt library, but APM can also provide and supplement this library in case if they are already with another EAM sort of vendor. So if they are a Maximo vendor, I think the right choice is to follow through on the Maximo reliability side of solution. Yeah. Yeah. So second question, I think this one is for Tony. So the question is, we are using another GIS system. Is there any other restrictions which regard to synchronizing the other systems with a linear model to the EAM?
Okay, interesting one. Maximo, so IBM have developed Maximo Spatial. Maximo Spatial is designed for Esri. So Maximo Spatial only works with Esri. Now, there are many other GIS systems. Small World is a very big contender in the utility space, but there are others. Now, two options, or a couple of options here. One is that there is a standard GIS interface which can be used. So we can take data in another GIS and present it as if it was an Esri data, so we can integrate using ArcWeb. Or what you can do is you can do a custom interface. We've done that on a number of occasions. So we have built custom interfaces to products like Small World. They're project specific, but you're getting the same functionality that you will get out of the spatial. So yes, you can use another GIS. It's just not off the shelf. It would need some configuration.
Okay, thank you, Tony.
Riley, we
I
have
think,
time for one more question. One more question.
Yeah, so there's one more question. I think this one is for Damien. So this is on the upgrade. So the question is, what is the average time to upgrade from an older version of Maximo to the MAS?
So that's an interesting question. I think Tony's smiling because he knows what my answer may potentially be. Short answer is it depends, and that is the whole purpose of our readiness assessment. What we often see is a number of customers go out to tender or go out to bid, expecting their respective vendors to give them the answer that you've just described without having a full awareness of what their current system includes. And so what we've tried to do is we've tried to package it and automate as much of that readiness assessment as possible to make it available to as many customers as possible, to better understand and identify and create awareness both from our perspective, so we know exactly what we're getting ourselves into, as well as the customer, so the customer can have a better understanding as to, firstly, what is the strategy that they take. We've had a lot of customers who initially wanted to do a pure technical upgrade, and then after identifying the extent of which the customizations would affect the upgrade, decided to change gear and to move back into a functional upgrade as well. So doing both enhancements on the business front as well as enhancements technically. To be very specific, if you are a very lightly not customized at all, if you are a very light user of Maximo, very easy system, very clean and cut and simple, there you would be looking at, I think, Tony, correct me if I'm wrong, yeah, anywhere from about 6 months to a year, obviously depending on the number of type upgrades there.
Yeah, no, okay, to actually do the physical upgrade would take about 3 days. However, very light, small user base, physical upgrade we could do in about a week. However, you'd probably want to test it. You probably want to train the users. You'd probably want to go through various rounds of governance. So typically, I'd say an upgrade is somewhere between 2 months and a year. If it's heavily customized, if you're doing major functional changes, if you're decustomizing, you're looking at the longer end. If it's very simple and very basic, it could be at the shorter end. And if you don't want any testing at all, we can do it very quickly. The other thing is we do have a tool called CDU, which basically means that for very large databases, instead of having the typical 4-day outage when you're doing the cutover, we're going to actually do a zero-time cutover. So we're going to effectively be running Maximo 8 in parallel with the old legacy Maximo 7.6, and the customer can cut over whenever they want. So we can actually avoid the downtime, which is a problem with critical systems. Okay.
Okay, thank you. I think with this, in lieu of the time, I thank everyone for attending this webinar, and we would probably conclude this session. We would have series of webinars coming up, and I would encourage every one of you to look for an attend in the future. So just a reminder that there will be a survey coming through to you. Please take your time and respond to the survey so that we can accommodate your requests in the future webinars, in the forthcoming webinars. Thank you. Thanks once again, Tony, Damien. That was a really great session. Thank you.
Thank you, everybody.
Thank you very much.
Thanks. Bye.
Thanks, Natasha.